Alright, in this lesson we're going to be talking about a concept called trigonometry. So trigonometry, again, only works in the context of right triangles, which is what we've been talking about in this entire unit. So there are three trig ratios that you guys need to worry about. There are others that you guys will learn as you continue on into pre-calculus and beyond. But the ones that we're going to be talking about are sine, cosine, and tangent, and they're actually on your calculator. So if you guys have your calculator with you, it's on the graphing calculator or any scientific calculator, really. If you guys look carefully, you guys can see the sine, cosine, and tangent buttons. That's what we're going to be learning about here in this lesson. So first of all, we're going to take a look at the three triangles that we have here. We have a smaller one, a medium-sized one, and a bigger triangle here. These are actually all similar to each other. And there are a couple different ways that you can see that, but the quickest one to notice is that they all have this angle in common and this angle in common, the right angle. So by angle, they would be similar. You can also do side, angle, side, whatever. You'll notice that the sides are proportional, and that's significant to see why sine, cosine, and tangent work the way that we're going to be using them. But what we're basically just going to be using these triangles for is to really see how the ratios work. So the first ratio we're going to be talking about is when you guys compare the side opposite the angle labeled. So these are all in your notes labeled with a little symbol called theta. That symbol right there. So that's called theta, and that's called the reference angle. The one that's labeled, or the one that they give you as a number, is called the reference angle. So here they have the little corner here on the left as the reference angle. The first ratio is the side opposite the angle to the hypotenuse. Remember, 2 is the way that they write ratios in words. So the side, let's say we're working in the smaller triangle right here. The side opposite the angle, right, opposite means across from, so that would be the 4. And then the hypotenuse is 5. So this ratio that they would want us to write would be 4 over 5 for this triangle, and then 8 over 10, and 10 over 12.5. Right? It's just whatever the side is opposite the angle divided by the hypotenuse. This is called the sine function, and then we're going to talk about that a little bit more detailed over here. But what you guys remember is that the sine, which they abbreviate as SIN, this is how you really spell it, but it's abbreviated SIN. The sine of whatever angle they give you is the opposite side over the hypotenuse. Okay? And I'm going to talk about these three letters in a second, but just remember that the sine is opposite over hypotenuse. That's how you set up the ratio. The next one we're going to talk about, the second ratio, is the side adjacent, not opposite, but now adjacent to the angle to the hypotenuse. So adjacent means next to. So opposite is across from, adjacent is next to. So if we're talking about, again, in this triangle, the side that's adjacent to the angle is this one that's touching it, the 3. Okay? So if I was going to write this ratio, the side adjacent to the angle, 3, to the hypotenuse, 5. So in the smallest triangle, the ratio would be 3 to 5, and this triangle would be 6 to 10, 7.5 to 12.5, right? So this setup tells you what sides you're going to be using as the ratio. And again, the way we write it officially, it's spelled cosine, it's sine with a co at the front, and we abbreviated that on your calculator as COS. So remember, the cosine is the adjacent side over the hypotenuse. That's how you would create the ratio when you're working with that function. So you have opposite over hypotenuse and then adjacent over hypotenuse. So it just depends on what side you're working with. And then our last one here is when you guys are working with the adjacent side. Actually, this one is mistyped. Go ahead and fix this in your notes. This should say opposite, and then this should say adjacent. Should have caught that. I think I copy pasted and then forgot to change it. This last ratio is supposed to be the side opposite to the angle and then to the adjacent side. Okay, so if you want to add the word side there. Mess that one up. So this is called the tangent. This is our third trigonometric function. We're going to be talking about the tangent. And again, that's described over here. It's the opposite over the adjacent side. So if I was working over here, again, the side opposite the angle is 4, the side adjacent to the angle or next to is 3, so it'd be 4 over 3, 8 over 6, 10 over 7.5. It depends on what the numbers actually are, but for every triangle, the value will be the same as long as they're similar. So if you want to test that in your calculator, if you do 4 over 3, 8 over 6, and 10 over 7.5 in your calculator, they should all be the same. because the triangles are similar, the tangent will be the same regardless of what size or length the sides are. Okay, so that's a lot more memorization in addition to what we did on day 2 with the special right triangle rules. So to help you guys, and you do need to know these. You need to know that sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So you do need to remember those. That's what's significant about these. That's how we use them to help us solve. But to guide you in that memorization process, we have a word that we use as a little kind of trick or an abbreviation or an acronym sort of to help us remember what these rules are. That word is SOHCAHTOA, and that's what these 3 letters are in each box. If you look at them all together, SOHCAHTOA. Some people make up a story about Chief SOHCAHTOA, like an Indian that hurt his foot, so he soaked his toe in water or something. I'm not exactly sure how that story goes. You can ask Mr. Williams if you know who that is, and he'll tell you the story. But if you just remember that word and how it's spelled, that will guide you through how to create these ratios. So the first part, the SO of SOHCAHTOA, is spelled S-O-H. That stands for the sine is opposite over hypotenuse, S-O-H. The ka in SOHCAHTOA is the cosine is adjacent over hypotenuse. That's the abbreviation there. And then TOA of SOHCAHTOA is the tangent is opposite over adjacent. So they took the first letter of sine, cosine, and tangent, and then they abbreviated opposite, hypotenuse, and adjacent with just those first letters of the words, and they spelled this word to help you guys memorize. So when you guys hear me saying SOHCAHTOA or writing it down, that's really just to help you guys memorize how sine, cosine, and tangent work. Okay? So a couple of things, important details you guys need to pay attention to. Again, theta represents the angle measure. They will be giving you an angle measure, a physical number when you guys are working with sine and cosine, or they'll tell you the angle name, like angle A or angle B or something. So you won't often see that theta symbol, but that's what they use when it's abstract and you don't actually have that information. Remember that the adjacent side to an angle is never the hypotenuse. The hypotenuse is its own special side, represented with H for hypotenuse. The adjacent and opposite sides have to be one of the 2 legs. So don't ever accidentally say that the adjacent side is the hypotenuse. Even though it's next to the angle, technically yes, but the hypotenuse serves its only purpose in the question. So the adjacent side would be the leg that's next to the angle. We have 2 different scenarios we're going to be working with using trig. If you guys are just using regular trigonometry, your generic sine, cosine, and tangent, like we're going to practice in a little bit, you're using that to find a side length. So if you notice that you are being asked to find a side length within a triangle, you would use regular trigonometry if you're given a particular piece of information. Specifically, if they give you the reference angle, right, and then they give you one other side. So if you have one angle and one other side, you can use trigonometry to help you solve. However, if they ask you to find an angle instead, right, instead of giving you the angle on one side, they'll give you 2 sides, or they'll give you what the trigonometric ratio is, and they'll ask you to find that reference angle. When you're doing that, you're actually going to use something called inverse trig, which again I'll talk about in a little bit, but there are 2 different scenarios. You're either finding a side length using regular trigonometry, or you're finding an angle using inverse trig. They're very closely related, so it's not that big of a difference when you guys are solving. All right, we're just going to practice by actually writing down the ratios. So you'll notice I'm not solving for anything. All I'm doing is I'm looking at this triangle that has all the information. I have all 3 sides, so I'm not trying to solve for anything. I don't need to know the angles. I'm just trying to write the ratio, the sine ratio, the cosine ratio, and the tangent ratio based on the angle that they're giving me. I don't need to actually know its measure, so I'm just going to write what it is as ratio. So for example, I'm trying to find the sine of angle n. So you need to know what angle they're talking about, so I like to circle it so I know what the reference angle is. I'm trying to find the sine of that angle. So remember SOHCAHTOA. SOHCAHTOA. The sine is this first part, the O and the H. So I like to write it like this to remind myself. The sine is opposite over hypotenuse. That's what the SO reminds you in the SOHCAHTOA word. So all I have to do is find what side's opposite n, which is 15, and then the hypotenuse, which is 25. We're all based on that triangle over there. And then obviously when you guys are writing a ratio or a fraction of any sort, you guys need to make sure it's fully simplified. So if I simplify that, it becomes 3/5. That's all they want. When they ask you for a ratio, they want you to write the fraction here using the sign relationship within the triangle. Same thing for cosine. Cosine is the CAH, C-A-H. Cosine is adjacent over hypotenuse. The side adjacent to angle N is the 20. That's the leg next to. And then the hypotenuse is 25. When you simplify that, you get 4/5. Okay? And then the tangent, again, is the TOA. Tangent is opposite over adjacent. Opposite over adjacent. Opposite N is 15. Adjacent to N, or next to, is 20. When you simplify that, you get 3/4. Okay, so when they ask you to write the ratios, that's what you do. Now, this next row right here is slightly different. The only thing that they've changed is what the reference angle is. So we're going to still find sine, cosine, and tangent, but now we're using angle C as our reference. So now the sides that are opposite and adjacent are going to be switched. They're going to be different because now we're looking at the triangle from a different angle. So sine is still the same ratio. It's still opposite over hypotenuse, no matter what. But in this scenario, since I changed to angle C, the side that's across from that is now 20. The opposite side from C is now 20. The hypotenuse is the same regardless. So this time it's going to be 4/5. So the sine of a different angle, the other angle that we were talking about in this triangle, that's 4/5. Which is interesting because the cosine of the previous angle was 4/5, but the sine is 4/5 for the other angle. So that's actually something that's really interesting, that these are kind of switched back and forth. The cosine of one angle is equal to the sine of the other. So that's kind of interesting, which actually happens here. Again, the sine of one angle is equal to the cosine of the other. So if I'm asked to find the cosine of angle C, cosine is adjacent over hypotenuse. The side adjacent to C is the 15, and the hypotenuse is still 25, and that simplifies to 3/5, which was the sine of the other angle. So that's a relationship that may come in handy in the future, so something to remember. And then the tangent is still opposite over adjacent. Opposite from C is 20. Adjacent to C is the 15. That simplifies to 4/3. So this just became the reciprocal of the tangent of the other angle. So they do have a relationship, and you guys are finding sine, cosine, and tangent of different angles. You'll notice how they kind of work with each other just because you're changing the perspective, but you're in the same triangle. All right, so that's when you guys are trying to find a simple ratio. You have everything that you need. You have all three sides. It doesn't really matter what the angle measure is because they've told you what angle to use as a reference. You really only will be given the angle measure when they're asking you to solve for a side because you don't know one. But again, in this one you had all three, so you just have to write a ratio as a fraction and simplify. Alright, to set us up for success on the next page where we will be seeing scenarios where you don't have all three sides and you'll be asked to solve for them, we're going to practice using our calculator to find the value of sine, cosine, and tangent. So you guys did that up here, right? You found the value of the function because you knew all three sides. You could just take the correct sides for each ratio and write them as a fraction. So like the one that was 3/5 as a decimal, that's 0.6. So the sine of whatever that angle was would be 0.6. What we're going to be doing here is practicing how to find the sine, cosine, and tangent of different angle measures. So depending on what the angle measure is in the triangle you're working with, you'll get different decimals. It's very easy. You guys have the sine, cosine, and tangent buttons in your calculator. All you have to do is push the sine button for this one, push sine, and then the number 31, and push enter. And that'll give you the number that you want. So for instance, you would get 0.52 when you guys are rounding. When we're working with trigonometry, you want to use 2 decimal points rounded, just so we're more consistent. It'll help your answer be more accurate if you have 2 decimal points. One thing to note, if you guys just tried that in your calculator and it didn't work, you got something else, then your calculator may not be in degree mode. That's something really important that needs to be set up in your calculator for you to be successful. So to get it into degree mode, you guys want to, let's see if I can do this. You guys want to find the mode button right here. And then the third row down, you might have radians highlighted. You don't want that highlighted. So you want to go over to the degree and push enter. And then that should leave the degree highlighted instead of the radian. So when you have it in degree mode, then it'll actually give you an accurate answer. Once you have it there, it'll stay there unless you clear your calculator. Right, then you just keep going. Cosine of 54 is 0.59 rounded. The tangent of 45 is 1. When you guys put it in your calculator, the sine of 25 is 0.43 rounded. Just kidding. 42. The tangent of 12 is 0.21. And then the cosine of 89 is 0.02 rounded. Okay? That's how you find your straightforward sine, cosine, and tangent when you know the actual angle measure. Now, there is something called inverse trig, which is when you guys are actually given this number and you have to work backwards to figure out what the angle was. So these expressions look different, right? You have the tangent of some variable, an angle that I don't know, is equal to blank, right? That's like these numbers that we just found, okay? So we're gonna have to approach this a little bit differently. When you guys are trying to go backwards, when you know what the value of the sine, tangent, or cosine is, but you don't know what the angle is, we use something called inverse trig, which is just using the second button on your calculator. I don't know what color it is for everybody, but on these ones, it's that yellow one right there. All you have to do is push second and then one of your functions, and you'll notice that it has that little -1 in addition to the sine, cosine, or tangent. That represents inverse. We have that little -1 there. So essentially what you're going to do is if you guys are going to swap, if you want to pull the angle that we're trying to solve for out here on the other side of the equal sign, you need to swap positions between these two. So in order to do that, that's the whole point of inverse trig. You get to swap the x and the y position of your function. So if you write tangent inverse of the number that was outside, you put it on the inside, and then the angle that you're looking for goes on the outside. So they just switch positions. If you type this into your calculator, second, push second, and then tangent, and it gets you the little -1, then you type 0.259. So it should look like this in your calculator. Hope you can see that. And then you push enter, you guys should get that number. All right, approximately 14.52. Right? So whenever you guys have this scenario where you guys know what the value of the function is, but you don't know what the angle was to get you there, you switch those two numbers to figure out what the angle was. That's the whole point of inverse trig. You switch those two numbers. So for this one, it would be sine inverse of 2.438 equals that f. When you guys put this in your calculator, second sine to give you the inverse of 2.438, you guys are going to get an error message. I will come back to that in a second, okay? Moving on to this, we're trying to swap these two to solve for the angle. So I do cosine inverse of 0.788 equals b. Swap those two using the inverse. So I do second cosine of 0.788. I get 38.00. Okay? Keep doing the same thing. If you guys do inverse tangent of 3.158, you switch those two to actually get what the value of g is. You would get hold on, I gotta figure that out. 7.43. All right, so that gives you that one. And then this one, again, you would do the inverse of sine, switch those two so you can actually solve for the angle measure. So you do inverse sine of 0.456, so second sine 0.456, you get 27.13 rounded. And then this last one, if you guys do the inverse cosine of 1.255 to try to get the angle E, you guys would end up with another error message. So what's so different about these two questions right here, the sine and that cosine question, that give you an error? But if you look really carefully at the values of the functions that you guys got for those two and compare them to all the other numbers, except for the tangent, because that's its own separate thing, you'll notice that the numbers that I tried here and here were bigger than 1. That can't happen. So for a sine and a cosine, remember the hypotenuse is on the bottom, it's on the denominator of fraction, and the hypotenuse is the longest side of a triangle. So let's say that we had a triangle like this, right? 3, 4, 5. In a right triangle, the 5, the hypotenuse, is always the longest side. And because the hypotenuse is on the bottom, if you guys try to divide something by a number that's bigger, you'll never get 1. If you try to do 3 divided by 5, that's less than 1. If you do 4 divided by 5, that's also less than 1. So if you try to do an inverse sine or cosine for a number that's bigger than 1, it's not going to work because you can't get that number in the first place. There's no angle measure that can get you a sine or a cosine that's bigger than 1 just by definition, because you're dividing by a hypotenuse, which is the longest side. So that's something that is interesting to know, that you can't ever get a sine or a cosine that's bigger than 1. You can for tangent. Tangent's fine because you're dividing opposite and adjacent. One could be bigger than the other or not. It really just depends what kind of triangle you're working with or what angle you're using for the reference, but it can't be bigger than 1 for sine or cosine. All right, on to the nitty-gritty. So this is what you guys will really be using trigonometry for, is when you guys have a scenario like this, and they're asking you to either solve for an angle or a side measure using trigonometry. Now, they're not going to actually say in the directions to use trigonometry, so you guys have to look carefully at the question to know whether trigonometry is the best method to use or not. So on lesson 1, we talked about Pythagorean theorem. The times that you would use Pythagorean theorem is when you don't have really any angles there, you just know it's a right triangle, and they've given you 2 sides and you're trying to find a third side. So you have a squared plus b squared equals c squared. Really straightforward. Day 2 is when we were talking about the special right triangles. That's when you guys have only one side, but then the angle that they've provided is either 30, 60, or 45. So you would have to use those rules that we memorized last time in order to solve with those. This scenario is actually very similar to the day 2 stuff. You will only have one side, right? And they're going to give you an angle. Or if you're doing the inverse and trying to find the angle, they'll give you 2 sides. But like for this scenario, if you guys look really carefully at our first one, I have one side and one angle. That's very similar to what we did in day 2. We had one side, one angle. But what's different here is that this 65 is not a 30, a 60, or a 45. So that's really important for you guys to know about trigonometry, is that trigonometry is only meant to be used when it's not a special right triangle, the stuff that we learned on day 2. If it's a 30, a 60, or a 45-degree angle, you have to use the rules that we memorized on day 2. Trigonometry is only to help you with the triangles that are not 30, 60, or 45, 45. That's the only scenario where you would use trigonometry, is if the angle that you have is not a 30, a 60, or a 45. Okay, so please be clear with that, because I'm expecting on the test that you guys use the most appropriate method to help you solve. So in this one, I notice I have one side, one angle. That's your setup for trigonometry. The angle is not 30, 60, or 45. So I will be using trigonometry to help me solve for this one. There are 2 variables. I'm going to solve for one of them, one at a time really. So I'm going to solve for the y first. You can start wherever you guys want to, but for the video I'm going to start with y. Now the best way to start the question to set you up for success is to label the sides with an O, an A, and an H. O for opposite, A for adjacent, and H for hypotenuse. So it's going to really help you figure out how to work with trigonometry. So my reference angle is right here, right? So across from that opposite, the angle is the x, the hypotenuse is y, and the 10 is the adjacent side. Do that first. It'll really set your foundation for being successful. So if I'm trying to solve for y first, I'm going to pretend that the x is not here. So if I cover that up, the 2 sides that I have are A and H. So think about the word SOHCAHTOA that helped us, right? The 2 sides that I have are A and H. What part of SOHCAHTOA has A and H? The A and the H in ka. Okay, so again, it's the A and the H in the ka part of SOHCAHTOA. So I know to solve for y, since I only am using A and H, I'm using cosine. Because that's the ka part, that's what the C stands for, the cosine. So in order to solve for y, I'm going to be using cosine. Well, remember, cosine of what? Whenever you guys are talking about sine or cosine or tangent, it's always in reference to an angle. So it's cosine of whatever the angle was that we're working with. So cosine of 65. You start there. You figure out what function do I need to use, sine, cosine, or tangent, based on the 2 sides that you have. One of them is going to be a number, the other one is going to be a variable. and then you just remember SOHCAHTOA so you know which one you're working with. So it's cosine of the angle. Now this is where you're going to use the rest of it. So I have ka. I have the A and the H. That's going to help you create the ratio that we were practicing before. It's the adjacent over the hypotenuse. So the adjacent side is 10, and the hypotenuse is y. This is really the biggest part of solving. You need to be able to write the equation correctly. You need to know whether it's sine, cosine, or tangent, and then write the equation. The rest of this is just algebra, okay? So for this equation, I have everything set up perfectly. I just need to get y by itself, because that's what I'm trying to solve for. So y is in the denominator of this fraction, so I want to pull it over to this side by multiplying. So that would put y over here, but then I want to get rid of cosine. So I would multiply the y and then divide the cosine. You can do those both at the same time. I'm fine with that. So a shortcut that I say to use is if the variable is in the denominator, just switch the variable with the cosine part of the equation. So it basically just turns into that. So all I did is I multiplied the y and then divided the cosine to get y by itself, and move the cosine in the place of the y. So this is all you would have to do to rearrange the equation, and then you literally just plug that in your calculator. You type 10 divided by the cosine of 65 and push enter. And you guys will get 23.66. That's all it really is. That's how you use trigonometry to solve. So I found one of the sides that they wanted me to find. I just found y. Y is 23.66 units, whatever it was. Now we're going to switch over to the x. Do not try to use y to help you solve for x for two reasons. If this is wrong, if you try to use that to solve for x, x will also be wrong. And then also because we rounded as a decimal, this is less accurate, right, than we actually want it to be. So you want to base your solving process on the accurate numbers that you have, which is the exact 10 right here and the exact 65. So don't try to use the y to keep going. There are some situations where you do have to do that, but if I have the freedom to ignore one of the variables I just found and use the previous existing information, do that. All right, so I'm going to pretend that this is not here. So without that information, the two sides I have are O and A, which is the tangent, the TOA of SOHCAHTOA. So I have the TOA, so I'm going to be using the tangent of 65. So I have the opposite and the adjacent. The actual ratio is opposite over adjacent with the way that it's spelled. So the x over 10. The opposite side over the adjacent side. Okay, so make sure you remember SOHCAHTOA and how it's spelled, how it helps you write the ratio. Now to get x by itself, I need to get rid of this 10 because it's in the denominator. I need to multiply it over. I don't have to do the same thing that I did over here where I divide again. That would kind of still make the equation messy. You want x by itself. So all you have to do is multiply both sides by 10 to get it to cancel out. Just put the 10 over there, right? And then you're good. So for this one, to get x by itself, you just multiply the 10 over, and then you would type that in your calculator. 10 times the tangent of 65, and you guys will get 21.45. Right, so there's a difference when the variable is on the denominator versus when it's on the numerator. If it's on the numerator, just multiply the denominator away, so you get rid of the fraction. But if the variable itself is in the denominator, you need to switch those two, so it stays as division. So that's just a little bit of algebra gymnastics you guys need to remember, but I'm counting on you guys knowing how to solve equations. So shouldn't have to go too in depth on that. All right, this next one's a little bit different. This time I want us to solve for an angle. So remember, this is what we were talking about before. If you guys are trying to find an angle, that's inverse trig. We're going to be working with this the exact same way. We're still going to label with O, A, and H. We're going to figure out what trig function I need to use, but the way that we're going to solve is going to be slightly different because we have to do that switch with the inverse trig. So for this one, I have the opposite and the hypotenuse. I don't have the adjacent side labeled with an actual number or variable, so you can ignore it. So the two sides that I have are the opposite side and the hypotenuse. If you look at SOHCAHTOA, the only function that has OH is this part right here, the SO, which represents the sine. So I'm trying to find the sine of. Now remember, inside the parentheses is where the angle goes. Right here, I don't know what the angle is, so I'm just going to call it y. So sine of y is equal to the opposite over the hypotenuse, 7 over 10. Now this should look familiar. I mean, it's a fraction instead of a decimal, but on the previous page we were working with things like that, where you had the trigonometric function, then a variable, or a letter here, is equal to some number. This is where inverse trig comes in. We want to know what y is, so I need to switch these two so that y is on the other side of the equal sign so I can actually solve for it. So this is where inverse trig comes in. We're going to take those two things and switch them, and then you type that in your calculator. Second, that's how you get the inverse, second sine of 7 divided by 10 gives you 44.43. And that's the value of y. Okay? So that's a slight difference between regular trigonometry for sides and inverse trigonometry for funny angles. Alright, this next one over here, again, two variables, so we're going to label all the sides with O, A, and H. So this is my angle. Across from that, the opposite side is right here. The side next to it, right here, is the adjacent. And then, as always, the hypotenuse is across from the right angle. So I'm going to solve for y again. First, if you pretend that the x isn't there, the two sides I have are O and H. Look back at SOHCAHTOA. Remember, the one that has the OH is sine. So I'm going to be doing the sine of the angle I'm given, which is the 32. Notice that wasn't a 30, 60, or a 45, so I know I'm supposed to be using trig instead of those rules we learned on day 2. So the sine of 32 is equal to opposite over hypotenuse, 10 over y. This is another situation where the variable is in the denominator, so I'm going to do that switch. So it would be y equals 10 divided by the sine of 32. If you guys need to do that in 2 steps, feel free. If you need to first multiply times y and get y times the sine of 32 equals 10, and then divide to get y by itself, you can break it up into 2 steps. But that's a cool shortcut that you can use, just knowing that you can switch the sine expression with the y automatically. Right? Then you just do 10 divided by, the sine of 32 in your calculator, and you get that y is equal to 18.87. This is the third question. All right, and then we're going to solve for x the same way. So again, you pretend that the y wasn't there. The two sides for x that you know are O and A. Right? Look at SOHCAHTOA. The O and the A are in the TOA part, so I'm going to be using tangent. So the tangent of 32 is equal to opposite over adjacent, 10 over x. I have the variable in the denominator again, so I'm going to use that switch. That multiply, divide in one step idea. And then I'm going to do 10 divided by the tangent of 32, 16.00. Okay, so just get used to labeling the sides OAH. Remember SOHCAHTOA and what it means, piece the equation together, and then solve using algebra. Oops. Next example is another inverse trigonometry question, and I can tell because it's the angle that I'm solving for. So again, I'm going to label the sides. This was opposite, but I don't know it. This is the adjacent side, and this is the hypotenuse. So the two sides that I do know for the situation is A and H. If you think about the word SOHCAHTOA, the AH are in the ka part, so I'm going to be using cosine. The C in ka is abbreviated, or it stands for cosine. So the cosine of what? Remember, it's the angle that goes in the parentheses, which I don't know. It's just a y. And then adjacent over hypotenuse, 4 over 5. This is where inverse trig comes in. I want to switch these two, so I'm going to use inverse trigonometry to do that. And then I can do second cosine, 4 over 5, gives me 36.87. Okay, hopefully you guys got that as you're working through. Alright, this next one is a little bit of a word problem. So it wants you to find the length of the diagonal. We've talked about that before. Obviously, a diagonal, when you first learn the definition of that word, means slanted line. So we're trying to find the diagonal, right? Technically, that should have a right angle there. I must have left that out on accident. That is a right triangle. The angle I have provided is 28, which is not 30, 60, or 45, so I know I'm going to be using trigonometry. I have one angle, one side, and I'm going to go ahead and use trigonometry here. So this side right here, which I don't have, that's across from the 28, so that's the O. You can put it there or not, doesn't really matter. But this side right here is adjacent, because that's next to the angle, and this one is the hypotenuse, the X, the side we're looking for. So the two sides again that I have are A and H, that's cosine from SOHCAHTOA. So the cosine of 28 is equal to adjacent over hypotenuse, the adjacent side, which is 20. You can write A over H at first if you want to, but then make sure you plug in the correct values. So the adjacent side is 20, the hypotenuse is X. So again, if the variable's in the denominator, we're going to do switcheroo. And type that into the calculator. 20 divided by the cosine of 28 is 22.65. Just like that. All right, next one over. Just another example. We have the side opposite, side adjacent, and the hypotenuse. If I'm solving for y first, I pretend the x isn't there. I have AH, so COHCAHTOA, so cosine. The cosine of 25. I'm using trigonometry because that angle is not 30, 60, or 45. Cosine would be adjacent over hypotenuse, so y over 20. When the variable is in the numerator, all you have to do is get rid of the 20, so it's not a fraction anymore. So we're just going to multiply the 20 on both sides so it cancels away. So the 20 comes over here instead, and I get y by itself that way. So I'm going to do 20 times the cosine of 25. That gives me 18.13. Okay, now pretend the y isn't there. If that's not there, then the two sides I have are O and H, which in your SOHCAHTOA is the sine. So I have the sine of 25 is equal to opposite over hypotenuse, x over 20. Right? Again, in this scenario, the variable is in the numerator, so all you have to do is multiply by 20 to get that to cancel. Make sure you do it on both sides though. So 20 times the sine of 25 is 8.45. That's the sixth example, I believe. There you go. So again, just more practice. Our last row here is a little interesting. So this is where I really wanted to introduce that idea of using different strategies at most appropriate times. So if you guys look at this scenario right here, I have two variables, y and x. The y is an angle, so obviously I'm going to be using inverse trigonometry to do that. But if you take a look at x is on the hypotenuse. If you look really carefully, if you pretend, well, we don't know y, so if you kind of imagine that picture without the angle there, that variable, what kind of scenario do you guys see? Hopefully, without this here, you guys should notice that you have you have two of the three sides labeled and you're just finding the third one. That's Pythagorean theorem. So I put this here so you guys can see trigonometry is not the solution to every single question. If you guys can use Pythagorean theorem and that's most appropriate, then use Pythagorean theorem. Sure, you can solve for trigonometry to find the value of x once you know y, but it's not the most accurate answer because trigonometry involves rounding and all that kind of stuff. When you use Pythagorean theorem, it gets you the most accurate most accurate answer because it's just a simplified radical. So if you guys saw a situation like this, you guys would have to use Pythagorean theorem. It's the most accurate process based on the information that you have. So we're going to go ahead and do that first. So because we don't know that angle, but we do know two of the three sides, we can use Pythagorean theorem. So a squared plus b squared equals c squared. Remember, c is the hypotenuse. So 4 squared plus 6 squared equals x squared. 16 plus 36, that's 52. All right, we practiced on day one, so it shouldn't be new. So you would end up with x is the square root of 52. Make sure you're trying to simplify if you can. So the square root of 52 can be split into the factorization 4 and 13. 4 is a perfect square, so that would be square rooted to become a 2. So you'd have a 2 on the outside, and because 13 can't be evenly square rooted, right? It would just stay as square root 13. So square root of 52 simplifies to 2 square root 13. So that's the value of x, using Pythagorean theorem, because that was the most appropriate method. Now we're going to go back and look at y. So remember when you guys are trying to find an angle based on sides. If you have sides and you're trying to find an angle, that's inverse trig. So again, we're going to stick with the 6 and the 4. I know that we just found x. We know what x is now, but again, it's a radical, first of all, and then second of all, if it's wrong, if you try to use that to solve for y, y would also be wrong. So just use the information that they've already printed for you in the question. So if we ignore the x, the two sides we have are opposite and adjacent. So think about SOHCAHTOA. The OA is the TOA part, so tangent. I'm going to be doing the tangent of angle y is equal to opposite over adjacent, 6 over 4. I'm going to be using inverse trig to get those to swap. And I'm going to do second tangent for my inverse trig, 6 over 4. My angle there is 56.31. Okay, so Pythagorean theorem to find x, inverse trig to find y. You have to be able to recognize the most appropriate method. Now this one right here is interesting. It's the same kind of situation over here, except we're missing this side, so I can't use Pythagorean theorem anymore because you need 2, and then you can find the third using Pythagorean theorem. For this one, I'm actually going to solve for y first. There is a way that you guys, well, you can use this expression right here to help you solve for x, but I'm just going to solve for y first because I noticed that it's probably the easier and quicker way. So because they've given me an equation, right? This is the equation very similar to this one that we wrote here. We had to do all that work of labeling the sides and figuring out whether it's sine, cosine, or tangent or whatever. They've already told you. They did that work already. They gave you that expression. So you have everything that you need to find y. This is just like what we were doing on the front side when they gave you that and they're asking you to do the inverse trig. So because y is an angle, we're just going to do the inverse trig of that equation that they gave us, and we have it. So remember when you guys, I know they don't have the parentheses, they don't always do the parentheses, but when you guys want to switch out the y, you use inverse trig. So we're just going to do the inverse trig form of that equation right there to solve for y, and we got it. So they did half the work for us. We just have to do inverse sine of 0.335, and I get that y is equal to 19.57. There you go. So the angle that we were looking for there is equal to 19.57. Let me just confirm that so I don't make a mistake. Yeah, so about 19.57 rounded. All right, so we found our angle. Now we're going to focus on finding x. All right, so the angle that we just found, the 19.57, that's not 30, it's not 60, it's not 45. So obviously we're not going to be using the special rules that we learned on day 2. We're going to be trying to use trigonometry. Okay? So the trigonometric function that we're working with is based on y, the angle that we found right now. So I am going to label the picture really quick. So this is opposite, and this is hypotenuse. So O and H, that's sine. That's actually why they give us this right here. They knew ahead of time that the function you would need to use is sine. Don't always try to guess that if they give you sine in the question that it's automatically going to be sine you're using the question in the solving process. It often is, but don't let them try to trick you into that. Don't make any assumptions even if they give you that information. So you label really quick, you confirm that it's sine that we're working with because we have opposite and hypotenuse. Then go ahead and write the equation for yourself so you can kind of see how it's going to work out, and then we can use that information if it's helpful. So I'm trying to find the sine of this angle, y, is equal to opposite over hypotenuse, 5 over x. Now there are 2 directions you guys can go in for this question. Because we solved for y first, and again I do kind of suggest that you not do this, but in this scenario you could, if you're really confident that this answer is correct, you could take the 19.57 and plug it in for the angle there if you wanted to. There is a more accurate way of doing this, but if you guys don't remember and you just see that you have the angle and plug it in and go from there, that's fine too. But the best way to do this is notice that I have sine y here, sine y right here. I also have sine y right there. They told me in this this problem here in this expression that sine y is equal to 0.335. So I can just swap them out. I can do substitution. So if I see that those two are equal, I can just write 0.335 right here and keep going from there. if you guys did here, let's just check really quick. If you guys had the 19.57 for the y and you did sine of 19.57, you'll notice you get 0.334958, blah, 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 blah. That rounds to 0.335, but again, this number is slightly different. So if you guys were to do this question by plugging it in, you would get a slightly different answer than what I'm going to get by using the rounded 0.335. Okay, so just know they're both valid methods. One of them will just be less accurate than the other because one rounds a little bit too early. But again, just do the one that makes more sense to you. You'll get the same general answer that you're looking for. But if they give you the information, they usually expect you to use it. So I plug in the 0.335. Because the variable's in the denominator, I'm going to do that switch trick. So x goes here, and the 0.335 goes here. I'm going to quickly divide 5 divided by 0.335 gives you 14.93. Like that. I think if you guys do the method where you plug the y in, you get 14.6 something. So it is off by some decimal values, but again, either method's okay. I'm fine with either. And then, really quickly, our last one here. Hopefully by now you guys have been doing them yourselves and just checking the answer on the video. This last one, I am asked to find a side length and an angle. When you look really carefully, if you kind of ignore the angle there, I have 1, 2, 3. I have 2 of the 3 sides, and I'm asking for the third one. Again, that is a Pythagorean theorem question. If you already know 2 of the sides and you're asking for the third one, you don't need to use trig. You don't need to use special right triangles. That's a Pythagorean theorem question. So this one again is a squared plus b squared equals c squared. So that's 169 plus 81, which is 250. Alright, I'm going to take the square root of 250. Alright, that's 25 times 10. Let me just double check on it. That's the biggest one. Yeah, that would be the biggest one. So then when you simplify it, the 25 is a perfect square, so that would square root to a 5. And the 10, which is not a perfect square, would just say square root of 10. So x as a value is 5 square root of 10. Right? So that's x. Now, when you guys are trying to find the value of y, the angle, that's when you're going to use trigonometry, inverse trig. Because you're trying to find an angle, you're going to use the 2 sides that they gave you originally, and you're going to use inverse trig to solve. I have opposite, the opposite side and the adjacent side. So OA, it's TOA and SOHCAHTOA. That's tangent of angle y is equal to opposite over adjacent. You're going to use inverse to get the y to switch with the number. And you get 34.7. So it's 0.695, and that round's kind of spiraling up to 7 on the 10th place. Alright, so that's trigonometry. We will be going a little bit more into word problems using trigonometry on day 4. But again, the most important thing to recognize is when to use trigonometry and when not to. So remember, when the angle is 30, 60, or 45, use the stuff from day 2. If you have 2 of the 3 sides and you're trying to find the third one, that's Pythagorean theorem. Trigonometry is only when you have one angle, one side, and the angle is not 30, 60, 45, or you're trying to find an angle where you use inverse trig. Okay?